Hey, Libby. There are 3 pages that you have today for section 6.2. The first one is this one that has 6 boxes. We're only going to fill in this top box, which means we have to hold on to this paper for like the next couple sections, right? Because we're going to fill this out as we go. So make sure you don't lose this guy. Then we have the notes for 6.2 and we have the homework assignment for 6.2. So we'll go through that stuff, but we're going to fill this box in first, just with the knowledge that we know about parallelograms to start with, okay? So we're going to fill this box based on stuff that we already know. We're going to draw a picture of a parallelogram. Do the best you can. The picture that comes to my mind when I have a parallelogram is he's slanted like, let me do a different color. I'm going to do it in black. He's slanted like this way-ish. I'm going to try my best. I'm really not a good drawer. Okay. Something of that nature. Just make him look something like that. You can tilt him the other direction, whatever. But this is the image that comes to my mind when I think parallelogram. Okay, we're gonna mark on him a little bit, so just get a base image drawn for him, and we're good to go. Okay, all right, we're gonna be studying this parallelogram. He's 4 sides. He doesn't seem like he's terribly interesting, but he does have like 5 unique qualities about him. The 1 through 5 means nothing other than just listing them 1, 2, 3, 4, 5. There are 2 important things to note about the sides of a parallelogram, 2 important things to note about the angles, and 1 thing that happens pretty special with the diagonals of a parallelogram. We're going to see if we can come up with all of these pieces of information. We're going to mark them on the diagram. Aside from the fact that a parallelogram has 4 sides, that's not included, and we already know that he's 360 degrees, that is not included in this stuff down here. So yes, it is a 4-sided figure. Yes, it's 360 degrees. Aside from that, we've got 5 more unique things about him. Okay, so let's talk about some sides here. And if we have this parallelogram, what's really unique about the sides of that parallelogram? Yeah, so I heard Angel say like the opposite ones are parallel, right? Okay, so I'm going to say opposite sides are parallel. Now, do you know what notation we use to mark this diagram to note that they are parallel to each other? The opposite sides are parallel. How do we show that on this diagram? No, they're not tick marks, because that would mean they're the same length. And same length is different than being parallel.
Arrows?
Yes, they're arrows. So we have an arrow here, and we have an arrow here. That means that those are parallel, right? They're going the same slope. They're sloping the same. And then this guy is parallel to this guy. And I'm using 2 marks, kind of like we would use 1 tick mark, 2 tick marks. I'm using 1 arrow versus 2 arrows. And those show which ones are parallel to each other, if it's not already obvious, right? It's pretty obvious already. Okay, sides. What other thing do we have about the sides? What else do we know about the sides? Yes. Are they all congruent? The opposite ones are congruent. So not only are the opposite ones parallel, but the opposite sides are the same length or are congruent, right? Okay, so we have to do some more markings. How do I mark that they are congruent? These are the tick marks. So I'm going to do 1 tick mark here, 1 tick mark here, 2 tick marks, 2 tick marks. Okay, that shows which ones. So not only are they parallel, but they are exactly the same length as well, right? That just makes sense, right? We know that, okay? All right, let's talk about the angles. What are some things that we know about the angles of these guys? The opposite angles are congruent. Opposite angles are congruent. So like this guy would be the same as this one, and this guy would be the same as this one, okay? All right, good. All right, this is the one that people forget all the time. Angles, number 4. Something else to note about the angles, other than the fact that they add up to be 360, right? I'm going to put some hypotheticals in for angles, right? Okay, so this is, let's say this is 50 degrees. We know that this is also 50 degrees, right? Okay, what would the other ones be? What? What ones? Yeah. So like this would be 130 and this would be 130. And what this is called is these are called consecutive angles. So just write that down and I'll explain it. C-O-N-S-E-C-U-T-I-V-E angles add to 180 degrees. Consecutive angles add up to be 180 degrees. Now, consecutive means ones that are right next to each other, okay? So we know that like these two right here, the ones that I just circled, you see that? Those add up to be 180. But also, do these add up to be 180? Yeah. And these add up to be 180. And these add up to be 180. Okay, now that provides me with a shortcut because I don't have to add them all up to be 360 to find any of the missing ones. I just have to take any two of them that are right next to each other and add them up to be 180, right? It just makes it faster for me, okay? So, let me erase all my little bubbles here, okay? So there is that, and then let's do one more thing. Let's add some diagonals in there, okay? And my diagonals are going from corner to corner and corner to corner, and there we have those. Okay, and we have to figure out what is true about the diagonals. They what? They meet in the middle. Okay, you're kind of on the right track. They meet in the middle. They meet in the middle. Okay, now, keep that in mind. Just wait a second. You're right, but we'll wait to reveal. Okay, now, are the diagonals the same length? Like, is this length here the same as this one? Okay, I'm gonna make this parallelogram a little bit more extreme here, okay? This guy, let's say my parallelogram instead goes like this. Let me make him really extreme. Okay, is this corner to this corner gonna be the same as this corner to this corner? No, right? But that's parallelogram. So the opposite corners, the ones that are slanty, is not going to be the same length, right? Like this one's going to be longer than this one, right? Okay, so that's not true. Is it splitting the angle in half? Like this guy, is he the same as that one? He doesn't look the same, but is that just my drawing or is it the way that it is? It does not split it in half. It's not just my crappy drawing, right? So my drawing is accurate. It does not split those in half, okay? But what it does do, you guys were kind of on the right track with saying that they like meet in the middle, okay? Even though this whole length is not the same as this whole length, what is true is that this length is the same as this one, right? So in other words, this guy is cutting him in half, right? Okay, and same thing the other direction. This guy is the same as this one. This one is cutting them in half. So each one is bisecting the other, just like Angel said. Erica said it a little bit ago, actually. I was just trying to keep her quiet because, you know, yeah. So the diagonals, they bisect each other. Okay, the diagonals bisect each other, which means they split each other exactly in half, right? They're not the same length total, but each half is the same as the other half, right? Okay, so here's how I'm going to mark this diagram, and then I'm going to tell you why Luke says I'm wrong. So there's this one and this one, and there's this one and this one, and he said, that's not going to work. Why is it not going to work? Like, that's correct that those are the opposite.
Because the other tick marks that
he said that this morning, and I'm like, technically you're right. So since we've already used one tick mark here and two tick marks here, we got to make it 3 and 4 tick marks. So 1, 2, 3, 1, 2, it just makes the diagram look terrible. Whatever. So technically that's what we should put down because, you know, those aren't technically the same as what the sides are, right? So whatever. He's right. It's just obnoxious. So anyway, whatever. Okay, makes sense? All right, so there's that. So whatever. So those are the 5 main unique qualities. Aside from the fact that we have 4 sides in a 360-degree figure, right? Aside from those facts, parallelogram, those 5 things are taking place, right? Okay. All right. So let's go down to the example, the notes down here. Okay.
Yeah. We've had enough.
Well, we're gonna. The rest of this is gonna take like 5 minutes of time. Not long. Okay. So the stuff that we just wrote down is this stuff right here. I'm not gonna go back through it again. So aside from the fact that it's a quadrilateral and has 2 sets of opposite sides that are parallel, these things are happening, which means the sides are congruent, the opposite angles are congruent. We have like these are adding up to be 180, right? All the way around, consecutive ones. And then this one says that if a parallelogram has one 90-degree angle marked, are all the rest of them going to have to be 90s? Right? We know that in a parallelogram, opposite ones are the same. So if this one's 90, then this one has to be also 90, right? But then these have to add up to be 180. So that makes this one have to be 90 and this one have to be 90 also, right? So if it has one 90-degree angle, they all must be 90s if we are truly looking at a parallelogram. So that's another thing. All right, let's go to this example. Whoop, I got some things labeled. Let's read through. We're going to mark this diagram. This is a basketball hoop. A basketball hoop has a parallelogram set up like on it so that you can raise it up and down. Like they use those in engineering stuff. You wouldn't think that there's like so much technologically stuff related to basketball hoops, but it's a thing. So the engineer who came up with the basketball hoop brilliantly did it this way so that you can raise that basketball hoop up and down very easily using like a, you know, like a what do I want to say? A rotation thing on each of the angles, whatever. So it's a parallelogram. That's how we have it going on here. And they say, suppose the measure of angle A is 55 degrees. So we have an angle that's 55 degrees. Okay. Then we have AB is 2.5 feet. Okay. Make sure that you're distinguishing between which ones are angles, which ones are sides. AB is a side. So they're saying that this side right here is 2.5 feet. And they're saying BC, which is another side, is 1 foot. Okay, and they're saying that this is a parallelogram, in fact, and they want us to solve some things over here. So they want us to figure out what DC is, the length of DC. Yep, we know the opposite ones are the same length, so it is in fact 2.5 feet. These are almost two easy questions, right? 2.5 feet. The measure of angle B, yeah, 55 is over here. We know that these two have to add up to 180, right? So 180 minus 55 is like 125. So B is going to be 125 degrees. And then they will also want to know angle C is 55 because it's opposite A, right? Okay, 55 degrees. These are not hard, correct? Yeah. What? That's like what your homework is basically, kind of. It gets a little bit harder when you're solving for stuff, so on the back side. Diagonals. Yeah, we're going to skip the proofs. Yeah. Diagonals, we know they bisect each other. Let's go down to the next section. Let's go to the top of the second page, which is example 2. And here, this is as hard as it gets. They have us solve for some things, okay? They have us solve for x, y, z. We know that this is a parallelogram. Let's locate x first. Oh, wait. Just look up on my diagram so we can see. 33 is this, 99 is this, 2y minus 5 is this, y plus 4 is this, 3z is this, 27 is this, and 5x is this. Do you see how that works?
27.
Okay. So 5x, Jalen says, is the same as 27 because the opposite ones are the same. So I'm just going to say 5x equals 27. And it doesn't come out nicely, but that's okay. 27 divided by 5 is 5 and 2/5, right? So 0.4. 5.4 is what x is. Yeah. Not too bad. Y, we have y's that are here and y's that are here. And what do we know about those two y's? They equal each other because that's the diagonals are bisected. And we can do some math here. So I'm going to subtract the y, and I'm going to add the 5, and I'm going to get y equals 9. And Haley had that like 20 minutes ago, but that's okay. Y is 9. Happy with that? Okay, now this one's a little bit tougher, maybe. I don't know. Z's. I only have one z, and it is right here in this corner. Oh, how do you know that 3z is equal to 33, though?
Because they are.
Yeah, so we know that this line right here is parallel to this line. Do you see that? And this line is a transversal. So this angle and this angle are going to be alternate interior angles. So 3z will be the same as 33, right? They're like reversed. So 3z equals 33 and divided by 3 and divided by 3, and z is 11. Okay, I'm going to label them over here. 11. Happy with that? Not too bad. Pretty easy. All right. We're not going to do the proof. We're just going to go through example 3 and be done for the day, and then I'll let you work. Let's graph these guys, and we'll see what we get here. So graph these guys. -2 is at 4, and 3 is at 5, and 2 is at -3, and I'll quit talking because I'm being annoying.
My line is curved.
Yeah, mine are not, because I have the luxury of just holding the pen down and it makes straight lines for me, so that's
I
nice.
can't remember who changed the iPad when they first got it and stuff, and like they could not figure it out. I think it was Feynman, and she was
Oh,
just
yeah.
freaking out. She was
Yeah.
freaking out. She's like, I don't know how to use this, and I'm like, ask co-measure.
Yeah. But I only know because people were telling me. They're like, did you know that when you hold your pen down, you can draw straight? I'm like, oh, what? Where did this come from? Whatever. All right, so what we're trying to find is, it says determine the coordinates of the intersection of the diagonals. So we're trying to find like this spot right here. And this morning they were guessing like 0, 0, but I don't know if it's what.
It's like 0 and a half.
0. Okay. So what we're gonna do is we're gonna find that point exactly using some math, and like Luke was saying, like, let's do the distance formula and then let's do this, and I'm like, no, let's not do that. So what we know is that, like, let's look at this diagonal right here. We know that this is gonna cut him exactly in half, right? In other words, this dot right here is called the midpoint, right? It's going to be the midpoint, okay? We have a formula for midpoint. Finding the midpoint is like finding the average, right? Like we're averaging those coordinates together, okay? And to average things together, you add them together. This is the formula. If you need to write it down, you can. Otherwise, whatever. Averaging the x's together, averaging the y's together. So we're adding the x's dividing by 2, adding the y's dividing by 2.
I definitely
Right?
had to do this today.
You did? Did you do it right?
Yeah.
Yeah.
But it,
Perfect.
It took me a really long time to remember the distance formula, and then when I did, I felt really dumb.
You know, it's okay. So, adding the x's together, we have an x here that's -2, and we have an x here that's +2. So -2 plus 2 divided by 2. -2 plus 2 is 0 divided by 2, so that's what we have for that one. And then the y's would be 4 plus a -3. 4 plus -3 divided by 2. What's 4 plus -3? 1. Okay? 0 divided by 2 is 0. 1 divided by 2 is just 1/2. So we have found the midpoint, and it is at 0, 1/2. Right?
That's what we were
Yeah, you were right. You're just so good. You're just so good. Now,
No proof?
technically, you only have to do one of the diagonals, but technically this guy's midpoint should be at 0, 1/2 also. So let's just check just in our brains real quick. -3 plus 3, if I add those together and divide by 2, we get 0, right? -4 plus 5, if I add those together and divide by 2, I get 1/2, right? Same thing. So you only have to do one diagonal, but you could really easily check by doing the other one, yeah? Okay, now, you have a bunch of these on your homework assignment, like 4 of them, I think, or something like that. But here's the deal. So on your homework assignment, skills practice, you do everything except the proof, which is number 9. Practice side, do everything except 11, which is the other proof. Okay? But let's talk about like 7 and 8 really quick. Okay? Because you can graph them if you would like to graph them. That is totally fine. But they tell me that this quadrilateral or this parallelogram goes HJKL. And when they say it like that, that means it goes in order, right? So if it goes in order HJKL, that means going around in a circle, it goes HJKL. Which ones will be opposite from each other? H and K will be opposites, J and L will be opposites, right? So you don't even really have to graph these in order to find the midpoint of the opposite ones. Either just pick H and K and find the midpoint, or pick J and L and find the midpoint, right? It doesn't matter which one you do. You could do both of them just to check and make sure you get the correct answer. But you wouldn't necessarily have to graph these. Does that make sense? Because they give us what it's named, we know that the opposite ones are the first and third one and second and fourth one, right? So we wouldn't necessarily have to graph. You can certainly graph if you want. Whatever, right? Make sense? Okay? Any questions? All right, I'm going to stop for Libby. Say bye, Libby.
Bye.